Hello class. So I'll show you how to analyze the PUMA 560 robot. This is the PUMA 560 robotic arm. So it has 6 degrees of freedom. 6 degrees of freedom. First is the rotation between the shoulder here and the trunk along this axis right here. Right? And the second is the rotation of the upper arm relative to the shoulder. Okay. And the third one is the rotation of the forearm relative to the upper arm along this elbow axis right here. And so that's three, right? And the fourth one is the rotation of this part, the wrist here relative to the forearm. So which is this one. Okay, the wrist rotate relative to the forearm along this axis. And the fifth degree of freedom is the rotation of the wrist along this axis right here. And the last is the rotation of the wrist along this axis right here. Okay. So first to develop forward kinematics for this arm, we need to attach frames to the link. Okay. So let's call this link. Here is the link number one. Okay. This is link 0 or the base. And this is the link number one. Okay, this link number two, link number three. Okay, link number four, link number five, and link number six. Okay, so this will be the joint one. Okay, joint one axis, right? Sorry, this will be joint one is this axis. Link 1 rotate relative to link 0 along this axis. So this will be joint 1. Okay, and this will be joint 2. Okay, this will be joint 3. Okay, this will be joint. Okay, so for the joint number 4, let's move to this image here. So link 4 rotate along this axis relative, this is link 3. Okay, so link 3 and 4 rotate relative to link 3 along this axis, right? So this is the will be the joint 4. Okay, link number 5, so this joint 4 or if uh, if we keep we rotate this image this direction, so join 4, make it easier to see, and this is the join 4, right? And this is link 4 right here. This is link 3. Okay, so link 4 is a piece that rotate about the joint 4 axis relative to link 3. Okay, this piece. Link 5 is this piece. Okay, this is the link number 5. This piece that that will rotate about this joint. So this is the link 5. And it rotates about this is joint number 5. Joint 5 is going into the plane. Okay, well, normal to the plane. So joint number 5 is, you can put here, is joint 5. Okay, and link number 6 is this piece right here. Okay, we rotate about this axis relative to link number 5. So joint 5, joint 6. This is a joint number 6. Okay, joint 4, joint 5, normal to the plane, the screen. Joint 4, and then joint number 6 is parallel to the joint number 4. Okay, so those are the joint. Okay, now we will affix frames, link frame to the arm. So okay, let me change this to number 2. So okay, so frame 1. Okay, let's do frame 1. So joint 1 is here, right? So this is joint 1. So Z1 will be along the joint 1 axis. Okay, and how about the origin of the frame 1? So the origin, to know the origin, you have to identify where is joint 2, right? This is joint 2 here. And if so, joint 1 is you have Z1 right here. And if Z2, if you have common perpendicular between Z1 and Z2, then the origin is at the intersection between the common perpendicular and the Z1, right? Origin of frame 1. But here you have Z1 and Z2. All right, so if you assume that you put the Z2 along the Z2 along the joint 2 axis like this, you put into this direction, so Z2 and Z1 intersect. So how you put the origin? The origin of link frame 1 will be at the intersection, so here, right? And x1, since they intersect, so x1 will be normal to the plane that perpendicular, normal to the plane that containing z1 and z2. So this is x1. Whereas in case you have z1 and z2, there's a common perpendicular between the two, then x1 will be along the common perpendicular, right? Which is not the case here. This is the case here. So x1 is the normal to the plane containing z1, right, and z2, and y1 is just follow the right hand rule right here. So this is right one right here, right? Now for the frame number link frame number 2, so you have Z2 along the joint 2 axis, this one. The origin of Z2, again you have to know where is Z3, so this is the Z3 right here, right? Okay, so between Z2 and Z3 you have, in this case, you have common perpendicular, right? And so you can pick there because they are parallel, so there are many common perpendicular, and so you can pick one of them. So let's pick this as a common perpendicular between Z1 and Z2. So it intersect with it meets the Z2 at this point, so you can put the origin of link frame 2 here. Okay, x2 is along the common perpendicular, so x2 is along the common perpendicular, so overlap with x1 basically, right? And then the y2, you follow right hand rule. So if you use index finger, point to the x, and so right, so index finger, point to x, and right hand rule, so index finger, right, so y will be pointing down. Okay, y2, okay, so y2 is here. So that you have link frame 1 and link frame 2. Okay, so frame 2 has they has the same origin with the frame 1. All right, link frame 3, so join 3 axis is here, and so this is Z3 right here. X3, okay, X3 you have to know where is a Z4, right? So Z4 is Z4 is actually this line right here, right? So this line right here. Okay, so if you look at this image, it will be a line, this line, a line that so Z3 is this, okay, or Z3, and look at this image is going into the plane, right? And Z4 is along joint 4 axis, right? So joint 4 axis, so Z4 is here. So there's a common perpendicular between the Z3, which goes into the plane, and then the Z4, which is this one. So this is a common perpendicular. So X3 is a so origin will be here, and then the X3 will be along the common perpendicular between Z3, which goes into the plane, and Z4, which are going down. Okay, so X3 is here, right? Or if you look at this image, it's right here, X3. Okay, and Y3 is follow right hand rule, right? So this is Y3. Okay, so this is a little bit tricky, but so it's easier to look at this image when you identify the Z3 and Z4, which is down here. And Z3 going into the plane. So there's a common perpendicular, and there's an X3 will be along that common perpendicular, right? Now we go to the, so we're done with the link frame 3, right? Link frame 3. Now we go to the link frame 4. Okay, so it's easier to go to this image, rotate this 90 degree. Okay, so Where is the joint 4? So joint 4 is here, right? So Z4 along this axis, so Z4 here. X, where's origin? Origin of of the link 4, we have to find where is the link, where's the Z5, right? So Z joint axis 5 axis, joint 5 axis here. Uh, so it's normal to the screen, right? So Z5 will be normal to the screen, right? So it will intersect with Z4. Okay, so therefore origin of link frame 4 will be here at the intersection. And uh, how about X4? X4 will be normal to the Z4, which is here, and Z5, which is normal to the plane. So X4 is normal to the plane created by containing Z4 and Z5, right? Y4 is follow right hand rule. So yeah, so it will be normal to the screen. Normal to the screen. Um, right. So link frame number 5. So link frame number 5. So again, Z5 is normal to the screen. Right. The joint 5 here, normal to the screen. So Z5 will be normal to the screen, and you can choose going out or going in. Here we choose going in. Okay, so the going into the screen, the Z5. Okay, so Z5 going into the screen. How about the origin of link 5? So we have to find where is the Z6, right? So Z6, joint number 6 is this axis. So Z6 is along this axis. Okay, as well. So this is Z4 and the yep. So Z6 along this axis. So Z5 is normal to the screen and go into the screen. So they intersect, and therefore the origin is of the link 5 is here. X5 also so will be normal to the plane containing Z5, which goes into the screen, and then the Z6 here. So X5 is also overlap with X4. Okay, X5. Y5 follow right hand rule, and so it will be um, it will be uh, along this axis, right? So Y5 this way. Yep. So you have X5 here and Y5 here. Okay, and Z5 going into the screen, and the origin is here. Okay, but uh, we draw it here and use the arrow to indicate that the origin is here. So how about the link frame 6? Again, where is the joint 6? Joint 6 is along this axis. So Z6 is here, like we said, right? Z6 along this axis. And then origin of frame 6, because we don't have C7, right? So we can put everywhere, but we can put at this point as well, so that we have zero link, zero in the tables, right? More zero in the table. So we put origin of link frame 6 here. X6, so again, there's no Z7, so no common perpendicular or the plane containing them. So we can put X6, we have freedom to choose what, but we can choose so that it has the zero, more zero in the table, so we can put x6 is okay. You can put x6. We can put x6 here. Okay, x6 here. So z6 here, x6 here, and y6 is then y6 you have to use right hand rule. So right hand rule like this: x up, right, z, and y6 will going out the screen. Okay, so z6, x6, okay, and then y6 going out of the screen. And the origin is here, not here. Okay, we put draw here, but we has arrow here indicated is actually here. And so you see that we have situation where z4, right, z4, z5 normal to the screen, and z6 here they intersect. Okay, so z4 here, z5 and z6 they intersect at one point. So this structure is quite popular in robotics, okay, for wrist of robotic arm. Okay, um, so now we will develop the table. Okay, link parameter table. Okay, so let's do it. First is the I equal 1. Okay, so alpha 0, right? Alpha 0 is angle between z, z, z0, okay, z0 and z1, right? Angle between z0 and z1, the angle. So z0 is z1. So link frame 0, we will put coincident with link frame 1 when link 1 at initial position, right? So z0 uh, will be overlap with z1, right? So there's no angle, and it's 0, and the a0 is the distance between 0 and z0 and z1, so they overlap, so no distance. D is the distance between x1 and x0, and it's the distance between x0 and x1, right, along the z1 axis. So again, x0 is assume that where is x1? X1 is here, right? Assume that x1 initial position is here. Then so there's no distance. Okay, they cut each other. The angle between x0 and x1. So initially x1 is here, but when the link 1 rotate, then there will be an angle between x1 and x0. So that angle is theta 1. Okay, the angle between x0 and x1 along z1 axis. Okay, for I equal to so alpha 1. Alpha 1 is the angle between z1 and z2, right? Um, so z1 is here and z2 is here. Okay, so alpha 1 and alpha 1 is the angle between z0, z1 and z2. Okay, angle between z1 and z2 along the x1 axis, which is here. Okay, So if you apply right hand rule for the x1 axis, then rotate this direction is positive, right? And the other direction is negative. So here you see that z1 has to rotate 90 minus 90 degree along the x1 axis to get to z2. Right, so it's going to be this direction is positive, right? This direction is negative, and z1 has to rotate negative 90 degree along the x1 to get to z2. Um, so therefore, alpha 1 is minus 90. Okay. Alpha 1, again, alpha 1 is the angle between z1 and z2 along x1 axis. Okay. And you have to rotate z1 negative 90 degree to get to z2. Okay, a1 is the distance between z1 and z2, right? Z1 and z2, and we know that they intersect, so there's no distance, 0. D is the also distance between x1 and x2 along z2 axis. Right, so x1 is here and x1 is here, okay, and x2 is here. Okay, x2 is here, so therefore there's no distance. Okay, angle between x1 and x2, so we have to be careful here. So although they, when you draw it overlap, but x2 is the link, is a frame for link 2, right? And x1 is the frame for link 1, and link 2 rotate relative to link 1. Okay, link 2 rotate relative to link 1 along this axis. So the angle between x1 and x2 will actually change. Right, it's a variable. So it's so alpha 2 is a variable. It's the angle between x1 and x2, and this is a variable. Okay. Now we go to the uh, I equals 3, right? So I equals 3, then alpha 2. What is alpha 2? Alpha 2 is the angle between z2 and z3. Okay, it's the angle between z2 and z3. So z2 is, where's z2? So z2 is along the joint 2 axis, right? And z3 is along the joint 3 axis. So is there any angle between these two? No, they parallel, right? So alpha 2 will be 0. Okay. A2 is the distance between Z2 and Z3. Is there any distance between Z2 and Z3? Yes, right? What is it? So yeah, we have to erase, it's A2, right? So it's A2. Okay. D3. So D3 is the distance between x2 and x3, right? Along Z3 axis. So x2, where is x2? So x2 is here, right? And x3 is here, right? X3 is there. And so the D3 is the distance between x2 and x3 along z3 axis, right? So x2 have to move this distance to get to along this to get to this, right? To get to x3. So Therefore, d3 is here, this distance. Okay, alpha 3. So alpha next is alpha 3. So alpha 3 is the angle between x2 and x3, right? So we have to be careful here again. So x2 is for the link 2, right? And x3 is for link 3. And link 3 rotates relative to link 2. Um, so the angle is a variable, not a constant. Okay. So angle between, although we draw it like look like they parallel, but when during uh, there's a rotation, there will be rotation and the angle will change. So this is the angle theta 3, right? So let's go to the next one, I equal 4. I equal 4 alpha 3. Alpha 3 is the angle between z, okay, z3 and z4. Right? So where's the z3? Z3 is here, okay. Where's z4? So we have to, yeah. So it's easier to look at this image right here to know. Okay, so z3 is along this axis, right? Z4 is along uh, an axis along this link, right? Somewhere along this link. Yeah, Z4. And so uh, do they cut each other or there's a distance? So to answer that question, we have to look at this image right here. Okay, so Z3 going into the plane, right? Z4 is along this one, so there's a distance between them, right? So this distance A3. So there's a distance. How about angle? Angle between Z3, which going into the plane, and Z4, which is this is what is the angle? Yeah, so it seems looks like 90 degree, right? What is the sine? So where is the x3? X3 is here, right? X3 is here. So um, the alpha I equal 4, so alpha 3 here will be alpha 3, right? Alpha 3 is the angle between z3 and z4 along about x3 axis. Okay, so x3 axis here, and we see that applied to right hand rule. So we see that the z3 which going into the screen has to rotate minus 90 degree to be aligned with the z4. Okay, so minus 90 degree. Okay, here will be the A3, right? So A3 is the distance between Z3 and Z4. So like we said, the distance is A3, right? Okay, next is here will be the D4. So yeah, here will be D4 is will be the distance between X3 and X4 along Z4 axis. Okay, so X3 is here and x4 is here, right? What is the difference between x3 and x4 along z4 axis? This would be d4. Okay, for here. And how about uh, alpha? Here will be alpha 4, right? So this is angle between x3 and x4 along the z4 axis. So x3 is here, x4 is here, and we have to be careful uh, because the link, so x3 is for link 3, right? X4 is for link 4, and link 4 rotates relative to link 3 along the joint 4 axis here. So the angle between x4 and x3 will be a variable, and it will be alpha 4. Okay. Next is the I equal 5, right? So here will be alpha 4. Right? Alpha 4 is the angle between z4 and z5 about x4 axis. So it's the angle between z4 and z5. So z4 is, okay, so z4 is here, right? Or if you look at this image, it will be here, right? And z5 is going into the plane. So, and x4 is here. So we see that z4 has to rotate plus 90 degree to get to z5, right? So x4 here using right hand rule. So rotating this way is a plus, and z4 has to rotate plus 90 degree to get to z5, which going into the plane. So it will be uh, plus 90 degree right here, right? Plus 90 degree. Okay, so z4. Okay, a4. Okay, here will be a4. So a4 is the distance between z4 and z5 along x4 axis. So they cut each other, right? So distance is 0. D5 is the angle between x4. This is the distance. Sorry, is the distance between x4 and x5 along z5 axis. So x4 is here. Okay, x5 x5 is here. Okay, so they basically they intersect, right? They overlap. X5 is here. So overlap regardless of a movement of 5 relative to 4, it will still cut each other, right? So there's no so x5 is for the link 5 here. Sorry, x4 is for link 4, and x5 is for link 5. And even if link 5 rotates along this axis relative to link 4, so x5 will be moved, for example, somewhere here, right? Then still, and x4 is still there, so they still cut each other, so there's no distance, but there will be angle. That angle is theta 5. Okay, next is I equals 6. So alpha 5, here will be alpha 5 is the angle between z5 and z6. Okay, and along the x5 axis. So where z5 is is going into the screen right here, right? Going into the screen, and z6 is here, right? So z6 is here, or you can draw here, right? So what is the angle between z5 going into the plane and z6 is here along the x5 axis right here, or you can draw it here. So yeah, what is the angle between z5 and z6 along x5? So you have to rotate z5, apply right hand rule for x5, right? So we will have to rotate minus 90 degree to get to z6, right? z5 going into the plane has to rotate minus 90 degree along x5 axis to go to z6 right here. So it will be minus 90 degree, right? And since they cut each other, so it's 0. So d6 is the distance between x5 and x6, okay, along the z6 axis. Again, x5 is here and x6 is also here. Right, x6 here, x5 here. They basically the distance, they cut each other, right? So uh, even if so x5 is for link number 5 here and x6 is for link number 6 here, right? Even if this one rotates relative to 6, they rotate relative to 5 along this axis, the x5 and x6 still intersect at this point, right? So there's no distance, but there will be angle. Okay. x5 is here, x6 here, and when the link number 6 rotate about the joint 6 axis, number 6 here rotates along the joint 6 axis, then x6 will angle, there's an angle between x6 and x5. That angle is theta 6, but since they always intersect at then there's a distance 0. Okay, so hope this helped. Thank you for watching.